Good morning, good morning, good morning all. So my dear friends, how are you? Are you present or not? Good morning, good morning. So Ashish is there, very good, very good. So my dear friends, I welcome you all to this second day session of the revision series of the smart series that we started. And my dear friends, let me tell you that I hope you are doing well. Gate is just after some days. And my dear friends, the focus of these sessions is purely revision, purely revision. I'm not discussing any new questions. I'm just discussing whatever you have studied and also clearing some small doubts and giving some small tips which is definitely going to help you in your examinations. So my dear friends, the last session that we did on 29th, I discussed three important chapters, three big chapters, that is calculus, and then it was probability, and then it was uh, linear algebra. Yes. And I got many messages that sir, notes, please upload the notes. And my dear friends, let me tell you that if you go to the Telegram channel, all the notes have been uploaded over there, or you will find all the notes. So students can go there and collect the notes, and the big three chapters are there. And today after the class, after doing the revision of the remaining chapters, that is vector calculus, then there is differential equations, then there is numerical methods, and there is complex number. After doing the revision, I will upload this notes also today. So today most probably is the last class from my end, because all the chapters mostly will be covered today itself, right? So my dear friends, Kalyani, the Telegram link is there itself. It has been linked. Okay. So my dear friends, without wasting any time, let's start today's session. And you can also ask your doubts. As well. Okay, my dear friends. So who all are present? They can let me know. Who all are present can let me know. Okay, my dear friends. So the first I'm going to start with the vector calculus. So on your screen, so Pranjali, yes, hello, chalo. So my dear friends, as you can see on the screen, the concept of vectors I have discussed. And position vector is what, my dear friends? Position vector is coordinate of a point with respect to origin, right? Very simple. So all these things are there. Length of the vector, my dear friends, is nothing but the magnitude, and all those things are fine. If anyone says what is the length of the vector, you can easily do what? You can easily just a minute. Let me start marking the important formulas. It will help you. So it is nothing but the formula which is given by root a square plus b square plus c square, nothing but distance from the origin. And sometimes, my dear friends, you need to convert it in unit vector form. So what we have to do, we have to divide it by its magnitude, and you will get the unit vector form. So all these things you know, and nothing much to say over there. Now my dear friends, product of two vectors is nothing but, it can be dot product, it can be cross product. So dot product, see, it will give you work done, and it is useful for taking projections. So in future, whenever there is a theorem that it is taking the dot product, that means it's nothing but it's taking projection, right? Whenever you need to take the projection of one vector over the other, remember that dot product has to come. And whenever some turning is associated with the vectors, so remember that you have to take the cross product. So all these things are useful when it comes to relating it with the important theorems that we discuss in vector calculus. So again, all these things, suppose in line integral, I say you that the vector is doing some work. So in that case, what will you do? You will immediately take the dot product, and you will not be surprised that why dot product has been taken. So this is the purpose, that dot product is used whenever work done is found, and cross product is used whenever the torque has been found. So what I have done here in this chart, I have just made a comparative study that where dot is used, where cross is used. And my difference formula, you know that A dot B is what? Mod A mod B cos theta. Mod A mod B cos theta. And you can also see over here that the formula is being attached. Okay, so this is the cross product formula. Okay, so my dear friends, this determinant form of the cross product, this also, I hope that you guys know about this formula. I hope you guys know about this formula, the cross product, the determinant form. Yes or no? So all these things are fine. Dot product is commutative in nature. Dot product is commutative in nature. But cross product is not commutative in nature. It is anti-commutative in nature. Anti-commutative in nature. Again, all these small points are fine. I'm not going to put much focus on these points because you already know these things. Area of parallelogram, suppose two vectors they give you. And they ask you what is the area of the parallelogram. So take the cross product by this determinant formula and you get the vector, and after getting the vector, find the modulus. So the area of parallelogram is given by A cross C, and you take the mod sign. Yes or no? And suppose they ask you area of triangle. So just half it, you will get the area of triangle. So again, remember that two vectors are given, area of triangle or area of parallelogram. Just immediately find the cross product, take its magnitude. Done. Now my dear friends, here comes the important things when it comes to vector calculus, that is the important terminologies. My dear friends, the first thing is what? Directional derivative. Always remember these crucial points in directional derivatives. But first of all, tell me, you guys have studied vector calculus or not? First of all, in the chat box, you tell me that have you guys studied about vector calculus? Have you guys studied about vector calculus? Tell me. Now what were things you have studied about vector calculus? You will tell me, sir, we have studied about directional derivative, we have studied about gradient, curl, divergence, and then, sir, we have studied about line integrals, then we have studied about surface integrals, then we have studied about the important theorems which connect all these integrals, and in these important theorems, we have studied about Green's theorem, Stokes theorem, Divergence theorem. All these things you will say that you have studied, and I'm going to say all the important things related to the whatever you have studied. My dear friends, directional derivative, always remember that in question, whenever directional derivative will be asked, you will be requiring two vectors and a point. Now, sir, what two vectors? Directional derivative, that means derivative in a given direction. That direction, a particular direction, need to be given. And since we are only concerned with direction, you are going to make it in unit vector form. So remember, the direction which will be given, you need to make it in unit form. So one vector you get over there. Second vector you get by finding the gradient of the scalar function. So second vector, gradient. So let me highlight it. Second vector, gradient. And unit vector you already have got, which is B unit cap. You take the dot product of that, and after taking the dot product, my dear friends, you are going to substitute the point in the function, and you will get the answer of directional derivative. Obviously, you are going to find it in scalar form or just the magnitude. So always remember, directional derivative, two vectors I need. One vector, that is the direction, will be given, and another vector I'm going to find it by the gradient. and a point which ultimately, at a particular point this directional derivative is always asked, so a point is always given. So these three things are needed to be given whenever you are finding directional derivative. So all these things are fine. Now my dear friends, how it is related to gradient, I will tell you. See, directional derivative, I've always also told in my division class that directional derivative is nothing but the derivative in a given direction. You change the direction, the value of dd will change. Now there must be a direction in which the value of dd is maximum. That particular direction is nothing but the gradient. So if I have to summarize, gradient is that direction in which the value of directional derivative is maximum. Very simple. So here I have shown with the help of car example that what I have shown here. Achha. First of all, how do you find the gradient? My dear friends, I have always already marked that del f by del xi, del f by del y j and del f by del z k. This is the formula for gradient. As you can see on the screen, I have highlighted it. Now my dear friends, there is a concept that gradient is always perpendicular to the level curve. Or suppose they give you a curve in the question that see this is the surface and just find the normal vector to this surface. Then what you find, automatically you are going to find the gradient. Sir, why? Because you know that gradient is perpendicular to the level curve. Whatever is the surface given, I need to find the normal. If I have to find the normal curve, it has to be the gradient. And this I have tried to show with the help of car going in a field where, whenever there is a perpendicular direction, the slope is maximum. So all these things are fine. And my dear friends, the first important point that you can see, I have already star marked over here, that gradient is always perpendicular to the level curve. Level curve is what? Something related to contour. Don't go into level curve, sir. What is level curve? Just remember that whatever surface you get, just take the, and they are asking you the normal vector, just take the gradient. Fine. My dear friends, divergence is always found for a vector. Remember, gradient for a scalar, divergence for a vector, curl for a vector. So divergence is given, you take the dot product with the del operator, and once you take the with the del operator the dot product, you are going to get this expression which you should remember always. Now my dear friends, what does divergence says? Divergence says the rate at which the vector field is expanding, the rate of expansion of divergence. Convergence means what? Converging to a particular point. Divergence means what? Diverging, going away, expanding. So rate at which vector field is expanding is called divergence, and the formula is given by this expression which you are seeing on the screen. And my dear friends, let me tell you that when I'm highlighting something, you know that you need to keep it in mind. That is the most basic thing, or the least expected thing that you need to keep in mind. Rest concepts I'm already helping you revise by whatever I'm saying it. So just remember the the highlighted portion, and whenever you download the PDF from the Telegram channel, you know that sir, whatever sir have marked in the PDF, I need to remember only those things. Fine. Now my dear friends, curl gives you what? Curl gives you the rotating effect of a vector field. Very simple. Suppose you go, you see a river and you see a curve, a kind of storm, whirlpool forming in the river, and suppose you throw some stick of wood in that river, the stick of wood starts rotating. That means you say that the river has got some, or the water has got some curve. Right? So whenever it comes to mechanical and civil branches, people can consider your water to be a fluid, they can consider to be a vector field, and electrical people can consider the electric field or magnetic field as their vector field. They can assume it and proceed. So my dear friends, this is the formula for curl as you are seeing on the screen. Curl gives you what? The rotating effect of a vector field. All these things are fine and everyone knows about this. And my dear friends, you can see that I have tried to show it with the help of a ball rotating. Suppose this is a vector field on your screen, whatever image you are seeing. See, this is the vector field which is rotating. A ball is kept, and this vector field is able to rotate the ball. That means it has got some curve. Simple. All these things are fine, my dear friends, and all these things are fine. I need not say much, just you need to remember the formula and proceed. Now, my dear friends, line integral, very important line integral, my dear friends, and just I'm going to summarize this line integral, my dear friends. See, in line integral, in a line, first of all, my dear friends, you need to recognize that it is a line integral question. Sir, integration along a line will be given, path will be given. Yes, sir, recognized. Fine. After that, what you need to do? See that whether the line given is closed or open. This is the first observation that you are going to make. Fine. Sir, let's say it is closed. If it is closed, apply Green's theorem. Done. If it is open, you cannot apply Green's theorem. In that case, what you need to do? Can anyone tell? If you cannot apply Green's theorem in a line integral question, what can you do then? You need to convert the variables in a given third, fourth variable, whatever is there. This concept is called parametrization. Yes or no? This is the general thing that any student should remember. Line integral, see that whether the curve is closed or open. If the curve is closed, apply Green's theorem. Very easy, very simple. 95% of the questions will be done. Very easy. If it is open, we have to apply the concept of parametrization. What is parametrization? Parametrization is, suppose xy variables are there and you need to convert these variables into the third variable and ultimately put the limits of that final variable. Ultimately put the limits of that final variable. This is the concept of parametrization. I hope everyone knows this. I hope everyone knows this. My dear friends, how will you identify that it is a question of line integral? See this expression. See this expression. Always remember that this is the expression used for line integral, my dear friends. F1 dx, F2 dy, F3 dz. No confusion over here. No confusion over here. This is the expression for line integral. Okay, so here on the screen you can see that this is nothing but the concept of parametrization. What is parametrization? That I have converted x, y, z in terms of a fourth variable which is t, and ultimately I have put the limits of that t in my integral. Very simple. So this is what you should look for in a line integral question. So my dear friends, in the PDF I have given examples of parametrization also, and by this concept you will be able to recognize whatever I have said. You will be able to correlate. So my dear friends, all these things are fine. And what is line integral, by the way? If some, although this is not that much important, but still, what is line integral? Line integral is a work doing capacity of a vector field. Work doing capacity of a vector field. Simple. So sir, work doing capacity of a vector field, that means dot product will be used, and see in the formula of line integral we always associate it with dot product. That means we are finding the line integral, we are finding the work done. So all these things are fine, my dear friends, and parametrization is also there. Parametrization means converting. Suppose a circle is there, xy is there. What are the parametric coordinates? X equal to a cos theta, y equal to a sin theta. A is the radius, t is the, or theta is the other variable. Put the limits of theta. This is the concept of parametrization. Means converting your variables into the one final single variable. Simple. All these things are fine, my dear friends, and so in the PDF you can see that I have showed you with the help of many examples what is parametrization, what is non-parametrization, what is gradient theorem. One theorem is also there, gradient theorem, but at this point I don't suggest anyone to go through this gradient theorem. It is not needed at this point. So all these things are there, my dear friends, and next let's go on to So many examples you are able to see. Now my dear friends, now comes the surface integral, which is there after line integral. What does the surface integral gives you, my dear friends? It gives us the flux which is passing through the surface. Heat flux, magnetic flux, electric flux, all these are nothing but calculated with the help of surface integral. That is fine. But when it comes to questions, in GATE, how will you say that yes sir, it's a question of surface integral, or they are asking me to calculate surface integral? See my dear friends, 99% of the question, whatever you are going to get in surface integral, will be done using Gauss divergence theorem. This automatically means that the surface will be a closed one, it will be covering some volume. Clear? So surface integral, so 99% chance is there that Gauss divergence theorem will be used, and that means the surface is a closed one. That it means that maybe they give you sphere, maybe they give you anything which is closed. 99% they will give you sphere only. That is also there. Now my dear friend, someone will ask me that sir, what if the surface is not closed? Sir, if the surface is not closed, then you cannot apply divergence theorem. I will discuss all the theorems, I will discuss, but I am telling you the gist now. Suppose I am not able to use divergence theorem, then my dear friends, there is a technique of projecting on the planes and then using a formula. Projecting on the planes and then using a formula. Projection formula. That means there are three planes available, xy, yz, zx. I can project it on any of the plane, convert it into a problem of double integral, and then use the formula to get the answer. This is also fine. Questions can come, but chances are very less, because I don't think that GATE will ask you to solve a one-page problem based on the projection formula. Projection technique is also there. Now what formula I am talking about? I am talking about these formula, my dear friends, that you can see on the screen. This is the projection formula. Now my dear friends, one thing, if you have studied somewhere or anywhere this projection formula, you know the concept, you will be able to use it very fine. Suppose you don't know this projection formula, straight away neglect it. Just focus on divergence theorem and how to use it. Straight away neglect it. If you have not studied, just leave it. Still, if someone wants to refer it, it is there in the notes. Fine. And sir, what does this projection formula does? It converts your surface integral into a problem of double integral, because surface integral deals with problems in space, double integral deals with problem in plane. So from space to plane, the plane dealing with problems on plane is relatively simpler. This is why. My dear friends, are you able to get this? Are you able to get whatever I am telling, my dear friends? So my dear friends, this is, see, in this problem, in the PDF, I have given a problem where this projection technique is also there. So if someone wants to refer, they can refer. Now my dear friends, the most important part of vector calculus, from where questions has to come, super important portion, and this is nothing but your theorems. My dear friend, how many theorems are there? 3 theorems are there: Green's theorem, Divergence theorem, and Stokes theorem. And my dear friends, I am going to discuss about these theorems in detail. That means the very important points, and just note these points, my dear friends. My dear friends, if I ask you Green's theorem, where can I apply, in what situation I can apply, and what are the things I need to keep in mind? My dear friends, Green theorem is used to convert a problem of line integral into a problem of double integral. First, line integral to double integral. Second, you can apply this only when the curve is a closed one. As you can see on the screen, it is a plane, xy plane, and the curve, see whatever I have shown on the screen, it is bounding a region. So line integral means going along the line, and when I am converted this into a problem of double integral, that means I need a region. What is that region? The region enclosed by the curve only, which is given by the red circles that I have drawn. Actually I have tried to show the curve, but small circles, all this I have drawn. So we have to find the double integral over there. Now it has concept with circulation also, which is going into the depth of Green's line integral, because line integral is also called circulation. So keep this thing in mind, that if a question tells you that find the circulation, that means you need to find the line integral. And circulation means what? In a circular path, closed path, that means Green's theorem will be applied. All these things you need to keep in mind. Now my dear friends, what is the statement of Green's theorem? Acha, when can I apply this? Before telling the statement also, when can I apply this? Everything must be in 2D. I am telling this again and again, that everything must be in 2D. Sir, everything must be in 2D means what? Vector needs to be in 2D. Vector needs to be in 2D, that means only xy or yz or zx, this thing. Second, plane, we are dealing with problems in plane, because Green's theorem converts into a problem of double integral deals with plane, so everything needs to be in plane, everything in 2D, simple. Third, very important, closed path and closed path. So see my dear friends, whenever there is a question of Green's theorem, I would want that the path is a closed one, because applying Green's theorem is very easy. Yes or no? I don't want to apply parametrization, because that is still fine, but it is going to take some time. So always I would wish that the problem comes from Green's theorem. That is the easiest thing that you can expect in vector calculus. Fine. Now my dear friends, coming to the expression. Chalo. See, this is f. Everyone can see na? This is f. F is obviously what? f1i plus f2j. Only two components because 2D. dr. Change in position vector. My dear friends, what will be dr? Suppose they have not given you dr. So don't come and say that, sir, they have not given me dr, I left the question. No. You know that r is what? Suppose they ask you dr. dr is nothing but change in position vector. dx I cap plus dy j cap. This is by default there. You don't need to do anything. Chalo. If you multiply, so obviously, suppose if I multiply f and dr, what I am going to get? I am going to get what? I am going to get f1 dx dot product na ijj, f1 dx plus f2 dy. Yes or no? And this is the line integral. So everything is 2D. You are able to see this. Very good. Now Green's theorem says double integral microscopic circulation into dx dy. Sir, why dx dy came? Because I am doing double integral. Fine. Sir, what is this microscopic circulation? The small circulations that I showed in the figure. Sir, what is that value? The value of the microscopic circulation is nothing but curl f dot k. Curl of f dot k. Sir, what is k? Unit cap perpendicular to xy plane. Curl f is what? Now my dear friends, this value of curl f dot k is nothing but what we generally memorize for Green's theorem, and this is del f2 by del x minus del f1 by del y. If you have memorized something for Green's theorem, it has to be this expression that is bounded by the very red lines. Yes or no? Tell me that yes sir, we have memorized this expression. Del f2 by del x minus del f1 by del y into dx dy. So this del f2 by del x minus del f1 by del y is nothing but the value of curl f dot k. Simple. Everything you are able to see in 2D, and this is nothing but the conversion into double integral. Now my dear friends, let me tell you that sometimes what happens that this del f2 by del x minus del f1 by del y value is 1, and once this value is 1, you are left with area of the region straight away. Because my dear friends, when you are converting in double integral, you have to apply all the concepts related to double integral, and you should know that when this this entire del f2 by del x minus del f1 by del y is 1, it is going to give me area of the curve. Now suppose your curve is a circle, apply pi r square. Suppose your area is a square, apply a square. Suppose your area is a rectangle, apply length into breadth. But suppose this value is not 1, then what I have to do? I have to apply the concept of purely it's a double integral question, and my dear friends, it is not going to give you the area of the curve, rather it will give you volume of the region. So these things are there in double integral. I hope you know the concepts of double integral. Are you are getting or not? You people are getting or not? Tell me. Or don't tell me that sir these things are going by tangential, in a tangent manner. You people are getting. Chalo. Now my dear friends, this is Green's theorem, and I've given the example also that how to solve questions of Green's theorem, and all the things I have. This is the question. Okay, so example is in front of you only. See, first of all, the question that is given to you, what is being asked, are you able to see that this is nothing but f1 dx? This is nothing but f2 dy. This is what? f1 dx plus f2 dy. Sir, everything is in 2D. 2D means what? X and y only. No z. Acha. Now, since it's a line integral question, they will give you some boundary. So the boundary they have given is x equal to 0, y equal to 0, and x plus y equal to 1. So sir, ready-made boundary is not given to you. You have to plot it. You have to plot it on the curve. And in double integral also, the first thing is plotting of the curve. All these curves you need to plot. So after plotting, I realized that they are asking me to calculate the line integral in this way, anti-clockwise. So after plotting the curve and noticing the path, is it not forming a closed path? Is it not forming a region which is closed? Tell me. And once it is forming a closed path, you know that line integral you know that Green's theorem has to be applied over here. So my dear friends, this is f1. You know what is f1, you know what is f2. Simply apply del f2 by del x minus del f1 by del y dx dy. All the things is fine, and you are arriving at a very good double integral question. You have converted your problem into a double integral problem. And once you have converted into a double integral problem, my dear friends, then you know the concept of strips and all this is, strip taking from this to this, put the limits of x, y, and just solve it. And in last class also, I think I have discussed all this concept of double integrals. Got it or not? You people are getting what I am trying to say? Chalo. So I think Green's theorem is clear. Green's theorem is clear, and if any doubt is there, you can also ask me. Now my dear friends, the most confusing part in the theorem portion is, sir, what is Stokes theorem? when will I apply Stokes theorem, and is it related to Green's theorem or not? My dear friends, let me tell you that Stokes theorem is nothing but the generalized version of Green's theorem. First, in Green's theorem, everything is in 2D, and in Stokes theorem, everything is in 3D because generalized. Third, how will I recognize that it is a question of Stokes theorem? It is $1 million question, because they are not going to tell you that, dear, apply Stokes theorem. No. Now, my dear friends, Stokes theorem, that means what? When I am generalizing it with the help of Green's theorem, there will be line integral, and there will be something that two integral limits, and something will be there, and ds will be there. Now, my dear friends, see one thing. Let me show you. Let me show you with the help of a figure. I'm showing you with the help of that how Stokes theorem is related to, how Stokes theorem and Green's theorem are related. Let me show you, my dear friends. Just a minute. See, my dear friends, in this table that you are seeing in front of you, here are the differences that is there in Green's theorem and Stokes theorem. Green's theorem, everything is in 2D. Stokes theorem, everything is in 3D. Now, my dear friends, remember that in a Green's theorem, see, line integral is there, so boundary will be there in Stokes theorem also, in Green's theorem also. Very good. Now, in Stokes theorem, that boundary was enclosing a region which was lying on a plane. But in Stokes theorem, that boundary will enclose a surface which is lying in space. Got it or not? That means there will be a surface in space, and you have to find the line integral along its boundary. That means the surface has to be an open surface. Then only you will be able to recognize its boundary. So boundary is common in Green's theorem, and it is also common in Stokes theorem. Boundary has to be there. Are you getting or not? So, my dear friends, you remember that in Green's theorem, what was there? See, in Green's theorem, there was curl f dot k into dx dy. Now, when I am going to write the expression for Stokes theorem, see, curl f is there. Achha, first of all, let's move on from the left hand side. F dot dr. The red one is the Stokes theorem. The black one is the Green's theorem. I'm writing this way. This is going to give you a very clearest view of both the theorems. The black one is what? Green's theorem. And the red one is what? Stokes theorem. And let's make a comparative study of both the theorems. This is going to give you a clear view. Chalo, let's move from left. F dot dr is there in Green's. F dot dr is there in Stokes. Very good, sir. Sir, in Green's there is f1 dx and f2 dy. That means it is in 2D. Only x and y is there. But when it comes to Stokes theorem, sir, you have added one extra dimension, which is f3 dz. That means it is in 3D. Again, left hand side is done. Now come to right hand side. Sir, here you have written curl f dot k, but here you have written curl f dot n. Now k is replaced by n. Sir, k was what? K was unit vector perpendicular to xy plane. But now we are not dealing in plane. Now we are dealing with a surface, and now I cannot say that k is unit vector perpendicular to the surface. Now I need to replace it with a n cap. What is n cap? Unit vector perpendicular to the surface. Very good. So dx dy is being replaced by ds vector, or ds is nothing but the area vector, and now I am not finding the double integral, rather the double integral is now being replaced by surface integral because I am dealing with space. This is the entire transformation from Green's theorem to Stokes theorem. And my dear friends, if you have managed to understand this transformation, it will be very easy for you. It is very easy for you. You just need to figure out this transformation that I am trying to show you on the screen. If you want, I can give you figure also. If you want, I can show it with the help of figure also. See, two figures are there on the screen. Two figures are there on the screen, and let's try to study. My dear friends, see, on the left hand side, there is a 2D plane. You can see a boundary. Yes sir, there is line integral, boundary will be there. It is enclosing a region, everything is in 2D. That means sir, it is a case of Green's theorem. So I am writing here sir, Green's theorem. Yes or no? Tell me in the chat box that are you able to figure out that yes sir, it's a case of Green's theorem. Now sir, when it is going to transform in Stokes theorem, that region which was there, the boundary was enclosing a region in the Green's theorem, but now there is a boundary. You are able to see a boundary, but now that boundary is enclosing what? It is enclosing a surface, and this surface you are able to see in a bowl shaped manner which is kept. Yes or no? Are you able to see that a bowl has been kept on the xy plane? That means a surface is there. Yes sir, now this boundary is enclosing a surface. That means it's a case of Stokes theorem. Now let me write here Stokes theorem. Now my dear friends, over here curl f dot k is there. Sir, why k cap? Because k cap is perpendicular to the xy plane. So I can say that if this is the xy plane, k cap is nothing but the unit vector perpendicular to the surface, and everywhere it will be k cap only. That's not a big deal. But now when it comes to Stokes theorem, I cannot say k cap because k cap will not be perpendicular everywhere. So there need to be defined a unit vector which is perpendicular to the surface. And that thing, my dear friend, I am showing now, highlighting now, which is there in the form of a vector. Are you able to see that vector? That yes sir, this is a vector which is perpendicular to the surface. This is nothing but your n cap vector. And my dear friends, suppose, can anyone tell me that what is this unit cap vector? Suppose they ask you that find the unit vector perpendicular to the surface. So suppose they ask you, so how will you find it? Can anyone tell? That suppose they ask you that find the unit vector perpendicular to the surface. So I've told you in the beginning that it is nothing but your gradient vector. It is nothing but your gradient vector. Always find gradient vector and get the answer. So my dear friends, if see, I'll only tell you this thing, that if this figure is clear, if the comparative study is clear, then there should be literally zero confusions in Stokes theorem. Now coming to how to know that it is a question of Stokes theorem, my dear friends. 99% chance is there that you will be given a particular vector in a Stokes theorem question, and let me show you what is that. Let me show you what is that vector. You will be given curl f dot n cap vector, you will be always look for this vector. If you manage to find out this vector, you know that it's a case of Stokes theorem. It's a case of Stokes theorem. Let me show you with the help of an example. Let me show you with the help of an example that suppose this is a question. Everyone read a question. Everyone read a question. Everyone read a question and you see by yourself that are you able to figure out that curl f dot ds vector. If you are able to find curl f dot ds vector, that means it's a case of Stokes theorem. You have to apply Stokes theorem and get the answer. Simple. So see, first of all, my dear friends, a vector field is been given which is in 3D. 3D vector field means what? Green's theorem cannot be applied. Gone. If S represents the portion of the sphere for this, a surface has been given. Okay, it might be Stokes theorem. But how will I know that finally I have to apply? Yes, 100% it's a Stokes theorem question. My dear friend, you have to look for this expression. Sir, how this expression is telling me that it's a question of Stokes theorem? My dear friends, this is what? This thing is what? This thing is curl f. Now ds vector. ds vector I can write what? N unit cap into ds. So my dear friends, see that it is nothing but curl f dot n into ds. That means it is what? The right hand side of the Stokes theorem. Right hand side of the Stokes theorem. Yes or no? See, over here it is the right hand side of the Stokes theorem equation. That means right hand side is given. You have to go to the left hand side. So I will quickly convert it in this way. Yes or no? I will quickly write it in line integral form and then apply the concept of parametrization to get the answer. But now I am 100% sure that yes sir, it's a Stokes theorem question and I have to apply the concept of Stokes theorem. My dear friends, are you getting these things or not? These things are the things which you have studied already. But there might be some confusion, so I'm trying to clear that confusion. Anyone is there or not? You people are there or not? Now, my dear friends, the divergence theorem, which is the final theorem which is there in vector calculus. My dear friends, as I said already in surface integral, that when divergence theorem is used, when they ask you to calculate the surface integral, first. Second, what is the criteria? The surface should be a closed one. The surface should be enclosing some volume in it. Then only you are able to apply divergence theorem. So it is very simple to recognize a divergence theorem question that sir, they need to ask me surface integral and the surface should be a closed one. 99% times they give us a sphere, but it can give me anything. That is fine. Now what is divergence theorem? See, on the left hand side there is surface integral that they are asking me. So what do I do in divergence theorem? I convert a surface integral problem into a problem of triple integral, and I do the triple integral of divergence f into dv. Now see my dear friends, divergence is very easy to find out. You calculate divergence, it's a scalar quantity. You take divergence out of the integrals. So basically you are left with triple integral dv, and triple integral dv is nothing but your volume of the surface which is enclosing a region. And if they give you that find this value at a particular point, so you put the point in the equation and get the answer. So my dear friends, I think that you don't have any confusion in the theorems that I discussed. Still, if any confusion is there, you can let me know. You can ask me that, sir, I have confusion over here. And if it is not, you can tell me, yes, sir, it's all fine. It's all fine. Tell me. Any doubt, my dear friends? Any doubt anywhere? Any doubt anywhere? Any doubt anywhere? So I think that there is no doubt in case of the theorems. And my dear friends, you can also see that there are few expressions, there are few identities from which questions can come. Now I have written all these identities over there. I have written all these identities over here, and some other useful identities I have also mentioned in the PDF. So if possible, you can go through these identities. You can remember these identities. Now these are some very rare identities. So I would suggest to, if possible, you can remember, but it's fine. If you are not able to do it, then it's fine. So identities I have also attached in this sheet. So I think I have talked on all the important points which is there in vector calculus, and you are going to get the question from here itself. If you have studied about vector calculus in detail, then you will be able to relate all the things. Now suppose you have not studied anything about Stokes theorem, you have not studied anything about Green's theorem, then how will you able to understand these things? Yes or no? So my dear friends, let's move on to the next chapter and let's discuss differential equations, my dear friends. Let's move on to the next chapter, and now let us discuss about differential equations, my dear friends. So tell me, you guys have studied about differential equations? Now my dear friends, whenever the concept of differential equation comes, one question you are going to get from second linear differential equation of second order. One question will be there. So I'll be discussing all the things in brief before that, and ultimately we will discuss that thing also. So my dear friends, 1 mark question can always come from order and degree. You need to keep in mind that the highest derivative occurring in differential equation is the order, and its degree is its power is called the degree of the differential equation. All these things are fine. Even if question comes, you will be able to do it. But you have to remember one thing, my dear friends, this order and degree you will be able to predict only when the differential equation is expressed in the form of polynomial. My dear friends, what is polynomial? I hope you know that in polynomial only integral powers of x are there. You are not allowed to mention the fractional powers. So if fractional power is there in the polynomial, convert it in integral powers by squaring, cubing, whatever. So all these things are there, my dear friends, because see, there is a question where root sign is given and you needed to mention order and degree. So since it is not in the form of polynomial, you need to convert it in polynomial first. So all these things are there, my dear friends. Now linear, non-linear differential equations, my dear friends. Again, my dear friends, linear means what? Linear means 1. So throughout the differential equation, if the degree of the dependent variable or its derivative is 1, then it is linear. If it is not 1, then it is not linear. Simple. So suppose you will find an differential equation in this way. Suppose this is y into dy by dx. So this is not a case of linear differential equation because the degree is 1 plus 1, 2. So therefore it is not linear. So all these things are there, my dear friends. Now similarly, homogeneous, non-homogeneous, my dear friends, differential equation is there. So again, what is homogeneous, my dear friends? Homogeneous means left hand side and right hand side of the differential equation must have a same degree, must have the same degree, then only it's a case of homogeneous. If it is not same, then it is not homogeneous. So suppose I write like d2y by dx square minus 5 dy by dx plus 6y is equal to x. So my dear friends, left hand side everywhere, the degree of the derivative and y is 1. But right hand side I can write y to the power 0. Y to the power 0, that means the degree is 0, not 1. So it will be a case of what? Non-homogeneous. So suppose if I have to make it in homogeneous, it has to be 0 over here. Very simple. So all these things are there, my dear friends. Now questions can come from there also based on the definition of, they will give a differential equation. They can ask you find the degree, order, whether it is homogeneous, whether it is linear. All these things are you can get as a 1 mark question. Now my dear friends, linear differential equation of first order. Linear differential equation of first order, or for one order, 1 degree, everything in the differential equation is 1. Then it's a case of this topic. Now my dear friends, let me tell you that whenever you get a question of the linear differential equation of first order, there are particular methods by which we need to follow. First is variable separable. Variable separable, my dear friends, we have already studied in your class 11-12. It is what? It is nothing but separating the one variable on the left hand side, separating the other variable on the right hand side, and integrate both the sides. Very easy. So, and how will you identify, my dear friends? It will be again, if you are able to separate the variables, so variable separable, no big deal. All these things you already know. That's why I'm not stressing over here. Why did I stress in vector calculus? Because I know that you guys are studying for the first time, so there might be some issue. But these things you guys already know. Achha. Homogeneous is what, my dear friends? You can clearly see that in case of homogeneous differential equation, I should be able to express in the form of y by x, and always remember that you will be getting terms like y by x in the differential equation. Whenever you are getting terms of y by x, there is a chance that it's a case of homogeneous differential equation. In that case, what we have to do, my dear friends? In that case, we have to assume y by x as v, y is equal to vx, and after assuming y by x as v or y equal to vx, differentiate with respect to x on both the sides, and once you differentiate with respect to x on both the sides, you will get the, the problem will be converted in variable separable and you will be getting the answer. This is also fine. Now my dear friends, next there is Libny's equation, linear differential equation. Libny's equation always is of this form. Libny's equation is always of this form. dy by dx plus p into y is equal to q. I hope you remember all these things. These are again the concepts from your earlier classes. You just have to remember the form and what is the final solution. Now suppose you get of this form, dy by dx plus py is equal to q, where p and q are either constants or the functions of fx So my dear friends, this is the final solution. As you can see on the screen that I have to write y into if is equal to integration q into if into dx. So again, this is the formula and you are expected to remember, and this is easy. If you manage to remember that what is Libny's equation, you know the final solution and you get the answer. That is particularly fine. Chalo. So integrating factor, all these things, my dear friends, you need, they can give you a question and they can ask you what is the integrating factor. All these things, my dear friends, you need to remember. Nothing, literally, what can I only say? I can only show you that these are the formulas, but ultimately you have to keep in mind. Keep Bernoulli's differential equation in mind, my dear friends. Questions can come from Bernoulli. Bernoulli is what? Bernoulli's differential equation is nothing but they will be the form, the equation will look like it is a case of Libny's, but in actual it is not Libny's. So what we have to do? So suppose you are getting a different linear differential equation of this form. So you have to divide by this y term throughout. Okay. After dividing it by throughout, you will be arriving at this stage. And from here, my dear friends, you have to take this y to the power 1 minus n as z. And after you assume this, ultimately your problem will be converted to Leibniz. And when it's get converted to Leibniz, you can apply your all the basics that you have studied about Leibniz. So Bernoulli's keep in mind. Now, my dear friends, linear differential equation of second order. Linear differential equation of second order. Before that, exact, non-exact is also there. So my dear friend, they can give you a function and they can tell you what is the total differential of any function. So total differential of any function is given by this thing, del u by del x into dx plus del u by del y into dy. Remember this is the total differential. Now, my dear friends, what is exact differential equation? You have studied about exact or non-exact. If a differential equation is there and you are able to express it in the form of total differential, then I say that it is exact. And if I am not able to express it in the form of total differential, I will tell that this is non-exact. Now suppose this thing, let me give you a very short example. This will make things clear. Suppose, my dear friends, see this thing, see the last, that the total differential of y by x is nothing but minus y. From here I have taken minus y dx plus x dy divided by x square. This is the total differential of y by x. Now suppose they give you that minus y dx plus x dy is equal to 0. So is this exact, my dear friends? No, this is not an exact differential equation. Now suppose I multiply with x square throughout. Now it is a case of exact because this thing I can write as the total differential of y by x, and once I am able to write in the form of total differential, it is exact. And if I am not able to write it in the form of total differential, it is not exact. Now you will ask me, my dear friends, that sir, how can we manually say that this is exact, this is not exact? Because for easier problems I will be saying, but for non-easier it will be difficult. So my dear friends, this is the condition which we generally use for checking that whether a differential equation is exact or it is non-exact. It is del m by del y is equal to del n by del x. It is the condition for exactness. I hope everyone knows this. And once you figure out that it is an exact differential equation, my dear friends, you have to apply this formula that you can see on the screen. M into dx plus n dash into dy is equal to constant. This is the formula, my dear friends, which you should apply for exact and non-exact. But my dear friends, questions are not coming that much from exact. I don't know why. That means in frequency of Leibniz, in frequency of variable separable, exact, non-exact is not coming. So there might be a chance that questions can come. So my dear friends, all these things are there in the PDF, and very beautifully solved examples are also there. You can very easily refer this and you can get the things. There can also be a situation that suppose a condition, a differential equation is non-exact. So in that case, you have to convert it in exact. How to convert it in exact? By multiplying with the integrating factor. How to calculate integrating factor? There is a formula. All these things I have mentioned in the PDF, my dear friends. So these things are there. Now, my dear friends, linear differential equation of the second order. Linear differential equation of the second order, my dear friends, you can clearly see the form that, okay, the highest order will be a second order and the highest order will be a second order, and on the right hand side x is there. My dear friends, everyone knows the process. I'm just trying to summarize it, that it will have two solutions. First is complementary function and the second is particular integral. Before coming into the steps as how to find complementary and particular, first it is important to know that what they are asking you in the question. Are they asking you the total solution? Are they asking you the complementary function? Or they asking you the particular integral? So first thing is this. So total solution is the sum of complementary function and particular integral. First thing. Second, how to find complementary function? By putting the right hand side as 0. Once you put right hand side is 0, you are getting a quadratic equation because it's a second order differential equation. Again, my dear friends, recall that a quadratic equation can have three cases. The roots are real distinct, the roots are real and similar, the roots are real and imaginary. Corresponding to the three cases, we have three cases over here for the complementary function, and if the roots are real and distinct, so the solution will be C1 e to the power m1x plus C2 e to the power m2x. I hope you know this thing. If the roots are real and repeating, in that case, my dear friends, C1 plus C2x e to the power mx. This also is there. See, already they are marked. That means, my dear friends, you have to remember only the highlighted portion and the concept that I am telling, right? I am trying to revise all the concepts that you guys should have studied. And finally, if the roots are complex conjugate of each other, alpha plus I beta, alpha minus I beta, so my dear friends, you have to finally remember this expression, which is again in the highlighted portion. In the highlighted, e to the power alpha x, C3 cos beta x, C4 sin beta x. Now, my dear friends, see one thing, that a second or nth order differential equation gives you nth constants, nth arbitrary constants. Suppose a second order differential equation is there. So when you solve it to get the final solution, you will be having two constants. So a differential equation, when you solve, it will be having complementary function. It will be having particular integral. So all the constants are given by the complementary solution. Any constant is not given by the particular integral. Always remember this thing in mind. So you can see, my dear friends, that when I am solving complementary function, always two constants are there because it's a second order differential equation. C3, C4 over here, C1, C2 is over there. So my dear friends, all these things are fine, and they can also ask you to calculate the value of the constants, and how you are going to do that? By using the conditions. Boundary conditions will be there, and using that you will be able to get the answer. So all these things are fine, my dear friends. And particular integral, my dear friends, whenever it comes to particular integral, there will be four cases, and within that four cases you will get the answer. First case, particular integral means what? Right hand side, which we intentionally put 0 to get the complementary function. Now x you have to put over there. When you put the x, you have to solve for particular integral. And again I am saying, my dear friends, that keep an eye on the question, that what they are asking. Are they asking only complementary, only particular, or the total solution? So let's discuss on particular. Right hand side, the first thing is, if they give you exponential function e to the power ax, my dear friends, all these things are algorithm driven procedure, and my dear friends, you just have to know the procedure, my dear friends, that first I bring the f of d function in the denominator, and then I substitute a. If they become 0, I differentiate. All these things are, process oriented, my dear friends, and I hope you know all these things. Now, second is the sine or cos function, my dear friends. In the always remember that in case of sine or cos function, always the substitution is d square is equal to minus of a square. D square is equal to minus of a square. Always keep this thing in mind, that in place of a square, in place of d square, I am able to put minus of a square. So this is one thing, my dear friends. Example is also given. Example you can refer in the PDF and you will get the idea. Chalo. Now, my dear friends, there can be algebraic also. Algebraic terms can be there. So whenever algebraic terms will be there, remember to use binomial expansions. Few binomial expansions will be used, which is there. Let me mark it as 1, 2, 3, 4. 1, 2, 3, 4 and 5. So these binomial expansions are there, and you need to express it in the form of 1 minus x to the power whatever, minus n or whatever. So always remember this thing, that in the form of 1 plus something, either 1 minus x, or it can be 1 plus x, or it can be 1 anything, 1 plus 1 minus x to the power minus 2, 1 plus x to the power minus 1, anything, it will be there, but it should be from 1 minus form only. So all these things are there, my dear friends. And the fourth case is also there. And fourth case questions have not come very much, but they can come. Generally, what are the questions from? Generally the questions are from either the exponential case, or the trigonometrical case, or the algebraic case. But fourth case is a mixture of exponential and any function of x. This thing, keep in mind that questions can come from here also. So in that case, my dear friends, I will separate the exponential one, and whatever is the a of a value, I substitute over f of d plus a kind and get the answer. So these are the things, my dear friends. And Euler Cauchy differential equation, my dear friends, it can come. It is important. Now, my dear friends, there was a case in 2019 where almost all the branch got a question of Euler Cauchy differential equation. So this is the standard form of Euler Cauchy differential equation, my dear friends. Standard form: x square d2y by dx square k1x dy by dx plus k2y is equal to x. Very standard form. So always remember that in Euler Cauchy, what is the substitution that I make? I make this substitution: x is equal to e to the power z, or log x is equal to z. This is the substitution that I make. And my dear friends, we have to manipulate. Actually, by this substitution, what do? We try to convert the case of variable coefficient into the case of constant coefficient, and then solve it using the previous knowledge that we have. So by making all the substitutions, like suppose in place of x square d2y by dx square, I made this substitution theta minus 1 into y. So using these substitutions, when I put these substitutions over there, it will be converted into a case of homogeneous constant coefficient. Like suppose this was a question. This is a question in front of you. So in place of x square d2y by dx square, I substitute this. In place of x dy by dx, substitute this, and after making the substitution, my dear friends, you see that ultimately we are converting it into a case of constant coefficient. Let me show you where it is. It is over here. And don't forget to substitute, means resubstitute whatever you have assumed in the beginning. Like suppose you have substituted let x equal to e to the power z. Now don't leave your answer in terms of z. Very, very important, my dear friends. Don't leave your answer in terms of z. You will not get any marks. Always take back to your answer in terms of x only. So these are the things, my dear friends. This is Cauchy Euler differential equations. And so what are the topics when it comes to differential equation? What are the topics important? Obviously, you can get question from the basics. 1 mark, that linear, non-linear, homogeneous, non-homogeneous. Second, you can get questions from linear differential equation of first order, where 4 methods are there: variable, separable, homogeneous, non-homogeneous, Libny's, then Bernoulli, and then exact, non-exact. Done. And the most important thing, where one question I always expect is linear differential equation of second order, CF, complementary function, particular integral are there. Complementary function, for complementary, assume right hand side as 0. For particular, don't have to ignore right hand side. Respective methods of solving. And finally, my dear friends, Euler-Cauchy differential equation, where it is a case of variable coefficient. And what do? I take some assumptions, which is x equal to e to the power z, and after taking some assumptions, I convert it into a problem of constant coefficients and get the answer. So all these things are there, my dear friends, and everything, literally whatever I am saying, all the things in a beautiful manner is being there in the PDF, and it is so easy for you to refer anything. Suppose you want to refer, suppose some student have not got, sir, what is Euler-Cauchy, so he can very easily come to the PDF, refer the process with the help of example, and if he is not able to understand, he can ask me also, no issue. So all the things are there, my dear friends. You just need to see that what is the thing you are forgetting at this moment. Whatever you think you might forget, just refer in the PDF. Everything is there, and it is nothing but my class notes only. Chalo. So all these things are there, my dear friends, and my dear friends, let us move towards see, there is partial differential equation also, which is there in the PDF. If a student has to revise partial differential equation, he can also refer this. Chalo. Now, my dear friends, complex number, and I think complex number is the portion from where questions will definitely come, and this is a bit neglected portion. And once you neglect this portion, confusions are bound to occur. So, my dear friends, in this short video, you will, after seeing this discussion on complex number, you will not have any confusion in complex number. Any confusion you won't have in complex number. This is my promise. And I know that where are the confusions. I know this very nicely, that from where confusions can come in this topic. So first tell me that, do you guys have studied complex number? Have you guys studied? Have you guys studied complex number? Tell me. Now my dear friends, let me tell you that complex number, the most important thing in complex number is complex integrals. That is the most important thing, from where a 2 marks question has to come. Now before that, all these things, modulus, then what is iota, I to the power 3, I to the power 4, all these things are there, very easy. I'm not going to stress a lot on these things. And modulus is there. What is argument of a complex number? The angle which the complex number is making with respect to the origin, that is your argument of the complex number. My dear friends, argument varies from minus pi to pi. As on the screen you can see that in the red color box I have shown that this theta varies from minus pi to pi, which is called the principal argument. All these things are again very easy, you are able to know that. E to the power I theta, always remember it is called cos theta plus I sin theta. It can be expressed as cos theta plus I sin theta. Then there is polar form of a complex number, and then there is De Mor's theorem. De Mor's theorem. All these things are very basic, my dear friends, but I hope you have remembered this. Now all these things are there, and my dear friends, the first portion, see, any question on complex integration you get, the first thing is plotting the line. Why? Because complex integral are also called complex line integral, and the concept is similar to the line integral of vector calculus. The same concept we can refer. And 99% the plot that we get in complex number is nothing but a circle which is there in polar form. So this is the circle which is given in the polar form. See, and my dear friends, from here what knowledge, what information you can extract? You can extract the radius of circle, you can extract center of the circle. Knowing those two things, you plot the circle, and this is the first step for any line integral question. Always remember this, always remember. So all these things are there. Now my dear friends, complex variable function. A complex variable function, it is going to have a real part, it is going to have an imaginary part. Everyone knows this? Very good. Now some special category of complex variable function, they are called analytic functions. That means the special complex variable function which are continuous and differentiable in their domain, mostly the continuous and differentiable, in general they are called analytic function. Again, they might be discontinuous or not differentiable at some point, which is fine. One or two continuity discontinuity points might always exist in any function, but a function which is analytic throughout the domain, throughout the Argand plane, that is called entire function. All these things are fine. Now my dear friends, what is the questions which come on analytic function? You know that there is real part, there is the imaginary part. So they give you the real part, they ask you imaginary part. Sometimes they give you the imaginary part, they ask you real part. So how to do such questions? Analytic functions, they follow Cauchy-Riemann equations. So with the help of Cauchy-Riemann equations, if one is given, you will be able to find the other. And the two equations I have mentioned, you can easily see on the screen, which is there on the screen, my dear friends. Using this Cauchy-Riemann equations, you can get the answer. Very easy. My dear friends, very nicely one example I have given from a GATE previous year question, where I have showed you that how without committing any silly mistake, you will be able to solve a question of analytic function requiring Cauchy-Riemann equations. I suggest you to go through this, although many people have their own methods of getting the answer. So I'm not going to stress a lot on that thing. Now, my dear friends, the most important is complex integration, my dear friends. And from here, questions are bound to come. From here, questions are bound to come. Now, my dear friends, there are something called singular points. You will be hearing these terms a lot in complex number. What is singular point? The point where the complex variable function is not differentiable, not analytic. Suppose for 1 by z function, you know that, sir, this function is continuous differentiable everywhere except at z equal to 0. So this z equal to 0 becomes the point of singularity. Done. Now, my dear friends, complex integration, if someone asks you that, can you briefly tell me what is the difference between the real integral that you have done and the complex integration? So always remember that in real integration, real functions integration, your reference was always the x-axis. The area you were finding, it was always with respect to x-axis. Yes or no? Always moving in one direction. But here, my dear friends, if someone tells you that find the complex integration between 2 points, so the path is not defined, the path is not clear. There can be many paths between 2 points. So if someone has to say he can do in an infinite number of ways complex integration between 2 points. First thing. Second, sir, if you can do, if I can do infinite number of times, infinite number of ways, if I can reach between 2 points, so sir, there must be some path mentioned. 100%. So in a complex integration question, a path is always given. This is the first noting that you need to do in complex number, that in any question path will be given. If there is no path, there is no question. Simple. So this is the difference between real and complex integration. Very good, sir. Now, my dear friends, remember in line integration I told you path will be given. Here also path is given. That is why complex integration is also called complex line integral. Fine. My dear friends, over there, remember how there were cases in line integral. How there were cases in line integral? I told you that, see, in a line integral question, if the path will be given, if the path is closed or if the path is not closed. If the path is closed, Green's theorem. If the path is not closed, parameterization. Same concept here also we will be using. Although we don't use Green's theorem and all those things like this, but the concept or the approach is moreover similar only. If the path is closed, we have Cauchy's theorem, Cauchy's integral theorem, and other residue theorem. If the path is not closed, now we generally assume that path will be closed and go in the examination. But path might not be closed also, and in that case what we do? Same, my dear friends, parameterization. That means converting one variable into the other variable is nothing but parameterization. I hope you guys are able to relate. Now, my dear friends, from now, whatever things we will discuss, it will be related to path closed type. Path closed type. So the first concept that comes over here is, now see, before discussing those theorems in the PDF, I have very neatly given example of parameterization also. So if someone wants to refer it, parameterization, they can refer it. Very easily I have given in, very easily explainable way. So all these things are there, my dear friends. So first is Cauchy's theorem. My dear friends, suppose you have a complex variable function whose integration you want to do. Now it is having a singular point. and that singular point is lying outside the closed path, or it is not falling in the region of the closed path. So automatically your answer will be 0. This is said by Cauchy's. This is meant by Cauchy's theorem. I drew the path. I saw that, sir, this singular point is not lying within the path. Answer is 0. Done. Very easy. Everyone knows this. Very easy. Yes or no? Now, my dear friends, very neatly try to understand these points, because the points that I am discussing over here, you won't, generally this is not dealt, in my opinion. So if you know these points, excellent, very good. But in case you don't know, please focus here, because these are the major confusions that I am talking about, which a student generally faces. Chalo. Now, my dear friends, suppose the singular point is lying within the path. In that case, Cauchy's integral theorem comes into picture. Yes or no? So my dear friends, this is the expression for Cauchy's theorem. This is the expression for Cauchy's integral theorem. I am highlighting it, yes or no? And you don't have to do anything. You just have to remember that, yes sir, we have studied the same thing in Cauchy's integral formula. You just have to study, you just know that, yes sir, this is the same thing that we have studied. Now, my dear friends, you need to know that this is 2 pi I, this is f of z at x equal to z equal to a. The f of z over here is not the entire function. The f of z over here is only the portion which is analytical. Always remember. So my dear friends, if you are applying Cauchy's integral formula, and if f of z, if in the formula over here, f of z is what? It is not the entire function, rather it is the analytical portion. It is the analytical portion that we are talking about. Okay. So these are the things, my dear friends, and you see, for any question I'm repeating again, that for any question, my dear friends, first you need to plot the path, then you will see that whether the singular point is lying within or outside. If all the singular points are lying outside, write the answer as 0, come back. If some point is lying inside, use Cauchy's integral theorem, get the answer, and fine. This is the thing. Now, my dear friends, see, I have given many examples over here. Many examples over here. Now, my dear friends, suppose that you have drawn the path. You have noticed that, sir, two singular points are lying within the path. You have noticed that, sir, two singular points are lying within the closed path. So in that case, my dear friends, it is always advisable to use residue theorem. It is always advisable to use residue theorem. So my dear friends, tell me, have you studied about residue theorem? So there are three theorems that is important in complex number. This I am discussing about Cauchy's integral theorem, and the only drawback of this theorem is you will be able to solve questions for two singular points, but not in a very effective way. It will consume some time. This is the only drawback. It will take some time. So better is, if there are one singular point, use Cauchy's integral theorem very easily. And if there are more than one singular points, it is always better to use the residue theorem, my dear friends. So are you able to get the things, my dear friends? Are you able to get the logic? Now, my dear friends, the second confusion you might get is, sir, there is residue theorem, there is Cauchy's integral theorem. Am I going to get the same answer from all the theorems? 100% yes. You are going to get the same answer from whatever theorem you use. Just know that how to use the theorem. Very simple. So my dear friend, this is the generalized formula for Cauchy's integral theorem, which I have encircled it. This is the generalized theorem, which is Are you people able to see? This is the generalized theorem that is there in your case of Cauchy's integral theorem, and I hope you know this formula. Chalo. So all these things are there, my dear friends, and I hope that now, my dear friends, power series comes into picture. Now for power series, I don't know how many students have studied this. What is Taylor series, what is Lorentz series. So I'm not going to put a lot of stress on their mind at this time, because it's fine if you have not studied, but if you have studied, it's again very good. So there is Taylor series, there is Lorentz series, the convergence I've talked about. My lectures are also there on convergence of power series on YouTube. You can also refer that. All the things are there. So all these things are there, my dear friends. And finally, my dear friends, Lorentz series, and then the concept of residue. The concept of residue, if someone asks you what is residue, residue is nothing but, my dear friends, the basic definition of residue is, suppose you expand a function by Lorentz series. In the principal part, that means where the negative powers of the z are there, the coefficient of 1 by z minus a is the residue. Always remember that what is residue? Residue is nothing but the coefficient of 1 by z minus z naught in the in the principal part of the Lorentz series. And if you multiply 2 pi I with that, you will get the answer. If you multiply 2 pi I with that, you will ultimately get the answer. And this is what is given by residue theorem. What is the residue theorem? Residue theorem is, once you know that these are my residue points, I multiply 2 pi I and get the answer. So suppose there is a function e to the power z divided by z minus 1 and z minus 2, and suppose you draw the path, suppose you drew the circle or path, whatever, and you saw that, sir, 1 is also lying, sir, 2 is also lying within the path. Now if you apply Cauchy integral theorem, you will be able to get the answer, but it will take some time. So what I will do in this case, I know that 1 and 2 are the residues. I can find the residue at point 1. I can find the residue at point 2. I will add them, multiply with 2 pi I and get the answer. So know when to apply what, and you will get the answer. Now suppose there might be a case where I am drawing a path. I am drawing a closed path. Sir, 1 is lying over here, but 2 is lying outside the closed path. So in this case, even if you want to apply a cost, how many singular points are there? 1. Only one point of consideration is there, which is 1. Means x equal to z equal to 1. So if I apply Cauchy's integral theorem, I will still get the answer in short time. If I apply residue theorem, you can also apply residue theorem. That also you can, answer you will be able to get in a short time. All these things are fine, my dear friends. So just you have to know that when to apply what case. And my dear friends, let me show you what is the residue theorem. So very easily you are able to see that you have to just figure out that what are the residues. My dear friends, the very important, the confusion which students face is that, sir, over here is fz dz. In Cauchy's integral theorem, there was also fz. So what is the difference between the fz over here, residue theorem, and the fz in there? Over here, my dear friends, fz refers to the entire function including the singular points. But in case of Cauchy integral theorem, your fz was only the term which was analytic in nature. Very, very important. Let me show you with the help of example. Now suppose, very, very important, my dear friends, I suggest you to see this thing. Suppose this is my function z minus 1, z minus 2. A student decides that, sir, I want to use Cauchy's integral theorem, and the theorem says 2 pi I into f of z at the singular point. In this case, my dear friends, what is your fz? In this case, your fz is only the term which is analytic in nature. Clear? And when it comes to residue theorem, your fz is what? This entire thing is your fz. Your entire thing is your fz. Remember this. Very, very basic thing, but very, very crucial at the same time. Now, my dear friends, how to find residue? Questions can also come on that. And if it's a pole of order 1 is there, so I'll be using the formula for simple pole. If pole of order m is there, I'll be using the formula for multiple pole. All these small things are there, my dear friends. Questions can definitely come from here. See, very, very important is there the formula for residue. They can individually ask you to calculate the residue at the points, and just you have to remember the formula. Now, my dear friends, the final thing which I would like to say in complex number is, see, one question I will explain to you, and where I will tell you that you use any formula in complex number, you are going to get the same answer. Now, suppose, my dear friend, this is the question everyone has. Now see this very carefully. This is the most confusing thing in complex number. This is the question that they have given to you. Suppose if I ask you, you don't know anything about this function, you see this function, and if I ask you, can you do the integration? You will tell yes, sir. Then you will ask, sir, can I do it using residue theorem? I will tell, very good, you can use the residue theorem. Then I will tell, then if I ask you, for residue theorem, you need to calculate pole. Yes or no? You will be needing to calculate residue at pole of order this. So if I ask you what is the pole, my dear friend, you will tell me, sir, pole is 0 of order 3 because z to the power 3 is there. Yes or no? If I ask you what is the pole of order what, you will tell me, sir, z equal to 0 is the pole of order 3 because z to the power 3 is there. My dear friends, do not conclude pole in this manner. Pole is always correctly told by Lorentz series. So if I expand this using Lorentz series, I will get that the pole is actually of order 1. Now that is a separate thing. This is a separate question, that what is the pole and of what is the order of the pole. But you have assumed that it is a pole of order 3 and you have applied the formula for order multiple pole and you have done the integration. But some student who actually knows that no, this is a pole of order 1, so I will apply the formula for single pole and do the integration. My dear friends, both will get the same answer. Everyone will get the same answer. Whether you apply the formula for pole of order 1 or you apply the formula for pole of order 3 or you apply the formula for pole of order 2, you will get the same answer. This is the most important thing that I am telling you, perhaps the most important thing of this discussion, that You apply. Now suppose if suppose anyone wants to use Cauchy's integral theorem, he can also use Cauchy's integral theorem and get the answer. My dear Vicky, I don't deal with advanced control, all these things. I deal only with maths. So I'm telling you all the things with respect to maths only. Okay. So my dear friends, please notice all these minute things, what is pole, what is residue, what is the formula for residue, what is the residue theorem, what is residue theorem, what is Cauchy's integral theorem, what is Cauchy's theorem, all these things, my dear friends, please keep in mind, these are very important things. Chalo. So always remember that whatever formula you use, whether residue theorem, Cauchy's integral theorem, you are going to arrive at the answer, Okay. So Vicky, I think I have already my lectures on YouTube for revising the probability. Please refer that. It is going to help you a lot. वो आपको काफी हेल्प करेगा. आप एक बार वो लेक्चर्स को देखो और उसमें काफी सिंपल तरीके से मैंने कॉन्सेप्ट्स को बताया है. और कोई भी डाउट होगा तो आप वहां कमेंट में पूछ सकते हो. ठीक है, चलो. सो I hope that there is no problem with respect to complex number, my dear friends. And my dear friends, numerical method. So in numerical method, what do I say? It is a formula based chapter, my dear friends. You remember the formula and you get the answer. What do I say over here? The most important, I can only say that the most important thing in algebraic is what? The most important thing in calculating the algebraic solution is Newton-Raphson method, where one question is going to be coming from Newton-Raphson method, which you can see the formula. And in integration, the questions will be coming from Simpson method and trapezoidal method. And in the final, which is your solutions to ODE, questions will be coming from Euler's method and RK method of order 2 or 4. So these are completely formula based chapter, my dear friends, and also the formula has also been mentioned over here. So just know the formula and get the answer. But for the previous chapters like complex number, differential equation, vector calculus, there were huge confusing concepts. So I stressed a lot on those concepts. But here it is completely formula oriented. Literally it's a formula oriented chapter. You know the formula, you solve the question. That's it. What do I say over here? And similarly it is in Laplace, my dear friends. Again, Laplace, you have to know what is the standard formula for Laplace. Question sometimes comes from the definition itself. In Laplace, what do we want to know? The main formula. Now, my dear friends, the electrical people are experts in Laplace theorem or Laplace transform. So I won't be telling anything to them because they usually deal with Laplace thing. And for the mechanical civil people, just know the important formula, just know the important theorems, and you will be able to solve the question. Acha. Also keep in mind questions are coming from inverse Laplace transform. Like let me show you one example over here, that questions are coming from inverse Laplace transform. Like in 2010 they give you this, that find the inverse Laplace for this. So for such questions, use the concept of partial fractions. Using partial fraction, disintegrate the fraction, disintegrate into single fraction, and then use the formula. Like they can also tell you that find the inverse Laplace transform for s plus 2 and s plus 3. So directly you cannot do. You have to disintegrate using partial fraction and solve it. So I hope all these things you know, my dear friends, and I need not say much about these things because most of the important chapters, almost all the important chapters plus concept I have discussed already in the previous class and in today's class. And if you refer these two classes, my dear friends, most of your confusions will be cleared. This I am very much sure about. Okay, so Vicky is asking, sir, mathematics level क्या रहेगा एग्जाम में? Vicky, लेवल कुछ भी हो, चाहे क्वेश्चंस बहुत टफ हो, चाहे क्वेश्चंस बहुत इजी हो, ऑलवेज रिमेंबर दैट इट इज फॉर एवरीवन. अगर आप नहीं कर पा रहे हो तो बाकी भी नहीं कर पाएंगे, आप कर पा रहे हो तो बाकी भी कर लेंगे. सो we should not go into the examination hall keeping the level in mind. Rather, we should always go into the examination hall keeping the basic concepts in mind. That कोई भी क्वेश्चन होगा हम बेसिक्स से ही करेंगे. If my basics is fine, if my basics is strong, I'll be able to solve the question. अच्छा, स्पेसिफिकली अगर लेवल की बात की जाए तो लेट्स से देयर आर 7 क्वेश्चंस इन मैथ. 7 में से 5 क्वेश्चंस तो वेरी इजीली और डुएबल होता है. यू आर वेरी इजीली एबल टू सॉल्व, और रैदर थोड़ा सा कंसेप्ट लाके 5 क्वेश्चन तो कर ही लोगे. 2 क्वेश्चंस में एम्बिग्विटी रहेगी. देयर विल बी 2 क्वेश्चंस वेयर it might take some time or you might not able to solve it. Totally fine. उसे छोड़ दो, आगे बढ़ जाओ. Leave that portion, go ahead. Do the other easier questions. You simply don't want to spend much time on those 2 typical questions rather than spending time on the easier questions which you can do. And later on, if you have time, come back to these 2 questions. And my dear friends, tell me one thing. We are BTech students. You are BTech students. Yes or no? We are BTech people. We know just by seeing the question whether we will be able to solve it or not. Yes or no? Just seeing the question and within 1 or maximum 1.5 minutes of time, we know already that whether we will be able to do something in that question or not within time. Yes or no? So you have to make those decisions very quickly. Yes, so this is the thing only. Rest you guys have studied all the things. Numerical methods, Ruby, I showed you that in numerical methods only few things are important. In suppose there are 3 areas: algebraic solutions, numerical integration, and ODE, ordinary differential equation. So in numerical in your algebraic solution, Newton-Raphson is very important. Bisection is also there. Regular false is also there. But Newton is very important. Questions has to come from Newton-Raphson method. And it is completely formula. This chapter, Ruby, is completely formula oriented. So what do I say in the formula? See, this is the concept for Newton-Raphson. This is the formula for Newton-Raphson. Again, there are 2-3 formulas in trapezoidal and Simpson, which is there on the screen. Yes or no? Tell me, am I right or not? That these are all formula oriented chapter. If you just have to remember the formula. Yes or no? So my dear friends, I think I have covered all the chapters, almost all the chapters, and I have discussed the important concepts and confusions where students might face problem. Also, my dear friends, before this smart revision classes, I took 6 classes for revising the important concepts with the help of questions, dissecting a question, discussing all the important details regarding a topic, and you can also see those lectures are there already on YouTube. So if you have time, you can go and refer those lectures. Suppose in case of probability you are facing any problem, you can go and refer that. Also, I am providing all the notes. These are all my class notes I have provided on the Telegram channel. So if you are there already in the Telegram channel, you have access to the notes also. This also I have done. And I have also told that suppose you are watching any lecture and you are not able to understand anything, you are facing any slight problem in understanding the concept, minute problem is there, you can comment below. I will try my best to answer those. Or you can contact our the Gate Academy to convey this doubt to Sourav sir. You can ask anything from me. So all these provisions are provided from my end. This is the maximum that we can do to help you in your revision. What more do you want? What more do you want? Ramesh, or error order for all the methods. For Newton-Raphson, it is 2. For second method, it is 1.67. For bisection, it is 1. That's it, done. And one more question you are going to get from here. They can give you what is the order of convergence for this method, what is the order of convergence for that method. Done. Then what more is there in error order? This is the thing. Yes or no? Yes or no? That yes sir, quadratic, there is quadratic convergence for Newton-Raphson. No, for Simpson and all those things, error order will not be asked. All these things will not be asked. No. O to the power 4, to the power 4, all these things are not going to be asked. No. You are talking about truncation error and all those things. No. See, I'll tell you what kind of questions they are going to give you in. Suppose I'm taking a Simpson method question. Let me show you how they are going to ask the percentage error. They will ask you what is the percentage error. So see, you remember this formula for percentage error. For any question, they will ask you what is the percentage error. So you remember that for percentage error, we need to calculate two solutions. One is exact solution, one is approximate solution. Exact solution you are going to get from analytical method, simple integration. Approximate solution you are going to get from numerical method, which is Simpson method. Yes or no? You use this formula exact minus approximate by exact into 100, you get the error. This is the error problem which they can ask in your examination. That's it. And same thing it is there in ODE also, ordinary differential equation also. Achha, see, in gate 18, what is the question they have asked? Read. In gate 18, what is the question they have asked? Ramesh, they have asked that this is the question: using Simpson, find the absolute error of numerical integration. So I have the basic formula in mind. I will calculate exact solution, I will calculate approximate solution, calculate percentage error, and get the answer. There, you are seeing now. See, this question is there. Let me show you one more question. Wait. I think it is not there, I guess. Suppose this question is there. du by dt. Suppose ODE question is there. So a differential equation question is there. They will ask you what is the percentage error or absolute error. So you use the Euler method or RK method to get the solution. That will be your approximate solution. You solve the differential equation from your analytical method, the way that you have studied in your differential equation. You will get one solution which becomes your exact solution. So you have two solutions: exact solution, approximate solution. You use the formula exact minus approximate by exact into 100, you get percentage error. Similarly, you can calculate absolute error. These are the error problems that you will be getting in your numerical methods. Okay. Any more doubts? From anywhere? So all the important things I have discussed. Any confusion regarding notes? Ruby, they have uploaded till covariance like rest of the topics. So Ruby, rest of the topics I taught you today. So today I will ask them to upload the notes for the remaining topics also. Okay, the topics which I discussed today, Ruby, the topic that I discussed today I will ask them to upload the notes for the remaining topics also. Done? Done? Any more doubts, my dear friends? Any more doubts? So I think no one is having any doubt regarding the notes, and most of the topics have been discussed on YouTube, so you can refer. And my dear friends, please stay calm, don't overload yourself. These topics which I have discussed in the sessions are only the conceptual points and some very key points. You saw that I am not taking any new question at this point of time because it is not going to do any favor, right? So my dear friends, all the very best, and do let us know that how was your exam. Do let me know, and please take care of your health, because you will be very tensed for the examination point of view. So wear mask properly, use sanitizers also. All these things are very crucial, and these are very basic things. So all the best, my dear friends. I wish you all the luck from me and my team, our team, the Gate Academy, my dear friends. Do let us know everything. Very good. God bless you. Let's meet soon. Chalo. So I'm ending the session and the notes will be uploaded. So goodbye, my dear friends. Goodbye. I hope the sessions was useful for you, my dear friends.